Chapter 2.4, Bar and Line Graphs. So for this chapter, or this lesson in this chapter, we are going to be creating bar and line graphs. Therefore, you need to have graph paper. Now, I know you don't have graph paper in your notebook, and that's okay. You can sketch it out. However, when you're doing your actual assignments, you need to be doing these on graph paper. If it helps you, you can always take a piece of graph paper, cut it, and glue or tape it into your math notebook so that you have them to create your graphs with. So the vocab for this lesson, we have two. We have bar graph and we have line graph. Now it's important to understand when you are going to use each. A bar graph is used for a comparison. When you are comparing two or more things. A line graph is used to show change over time. A line graph has one thing. Okay, bar graph has two or more, a line graph compares one. You also need to know your axes, X and Y. The labels, titles, horizontal and vertical, these are terms we're going to be using, and things that you may need to show on your graph. So let's start with example 1, a bar graph. Make a bar graph to display the data in the chart. Compare the amount of calcium in milk to the amount in cottage cheese. So, I see several things here. I see a title. The title of this chart is going to be the same as the title of my graph. Calcium content. Then I see a food item for 1 cup of food. This is going to be my x-axis. These are my foods, my milk, yogurt, cottage cheese, ice cream, and broccoli. The amount of calcium in milligrams, this is going to be my y-axis. So, how do we start? Well, I need an x and y axis. Now, normally you would be doing this on graph paper, so yours would be very straight and neat. So the y-axis is the vertical axis. The x-axis is the horizontal. If you're not 100% comfortable with those, go ahead and label them as x and y until you just know automatically that those are the x and y axes. So we already determined that the food item was going to go on our x-axis. So our label is food, and our amount, how much food, goes in parentheses, just like it is here in our table, is how it's going to look like down here. And my foods are milk. Normally you would write them all out, but for space, I'm going to just write the first letter. Yogurt, cottage cheese, ice cream, and broccoli. Now, the y-axis is my calcium. You're going to write calcium in parentheses milligrams to show how we are measuring. Are these milligrams, grams, how much is it? So then I have to figure out how to label. So I see a minimum of 80, and I see a maximum of 300. So the difference between those two is 220. I think I'm going to go ahead and count by 50s. It doesn't matter what you count by as long as they are even. Okay? So if this is 0, 50, 100, 150, 200, 250, 300, 350. Okay? They just have to be even. Count by ones, count by tens, count by twos, count by 50s. It doesn't matter what you count by as long as it is the same starting from 0. Okay? So now I have my x-axis, my y-axis, I have my labels, I have my title. Now I'm ready to actually make my bars. So, milk has 300 milligrams. So I'm going to draw a bar. Stop. There we go. From there we go. And you are neatly going to color it in. So notice, my top of my bar is right at 300. There is a space between my y-axis and my first bar, and it comes all the way down to 0. Next is yogurt, which is 250. So I'm going to go up to 250. My bar needs to be the same width. All of the bars should be approximately the same width. When you're using graph paper, 1 square is perfect. All right, cottage cheese, 150. Ice cream, 200. And broccoli, 80. Okay, so I know that 80 is between 50 and 100. It's slightly closer to 100 than it is to 50. So my bar is going to be in between 50 and 80. Okay, so there you have it, a bar graph. Notice my bars are all evenly spaced apart. They're the same width. The only difference is their height. So the question says, compare the amount of calcium in milk to the amount in cottage cheese. So milk has 300. Cottage cheese only has 150. The difference is the space between them, or 150 milligrams. So the amount of calcium in milk is twice as much as in cottage cheese, or 150 milligrams more than cottage cheese. All right, let's go talk about a line graph. So a line graph uses a series of small lines to show change in data over time. So time is always x. Time is always on your x-axis. In a table like this one, temperatures throughout the day, tables always have the x-axis on the left and the y-axis on the right. Time is always x. So this graph needs to have the same things as our bar graph. It needs to have a title, temperature, and I'm going to abbreviate temp through the day. It needs an x-axis and a y-axis. Make sure you're spacing this just a little bit in from the edge of your paper so that you have room to write your axis label and all of your temperatures or whatever information goes on that side. Then we have our x-axis. So this one is time. This is my temperature. And my temperature is in degrees. Oh, go back. Fahrenheit. All right, so it looks like I'm starting at 8 a.m. and going to 6 p.m. counting every 2 hours. That's totally fine. I'm going to start at 8. Actually, I'm not. I'm going to put 8 a.m. right on the y-axis, because we don't know what the temperature is before that. 10, 12, 2, 4, and 6. Again, yours will be much neater being done on graph paper than mine is not on graph paper. So please make sure you use your graph paper. Okay, my temperatures. Again, I need to identify my high and my low. 62 looks to be my low and 81 my high. So I'm going to start at 60 and I'm going to go up to 82 and I'm going to go ahead and I'm going to count by fives actually. So that I don't have to start from 0, I'm going to put this little zigzag line right here. This means that there are temperatures between 0 and my first temperature of 60, but I'm not going to list them because that's going to make my graph really, really long. So I'm going to start at 60, 65, 70, 75, 80, 85, 90, and that's plenty. So at 8 a.m., it was 62 degrees. So at 8 a.m., I'm going to place a dot where 8 a.m. and 62 degrees intersect. At 10 a.m., it was 70 degrees. So where the line for 70 degrees and the line for 10 a.m. intersect, you're going to place another dot. Noon, it was 78 degrees. So not quite 80. Stop. There we go. At 2 p.m. it was 81 degrees, just a smidge higher. At 4 p.m. it was 76 degrees, starts to come back down and get a little cooler. And at 6 p.m. it was 74 degrees. And now I'm going to neatly connect the dots. I'm going to recommend you use a ruler. It tends to make your lines significantly straighter and neater than I'm making mine right now. Okay, so I have my title, my axis labels, time and temperature, my times, my temperatures, and here is my line graph. So example 3, which type of graph should you use and when should you use it? So here we have 3 types, an organized list, a bar graph, a line graph, and a frequency table. So quick review. An organized list is just that. It's a list of data. Bar graph, comparing, okay? Comparing multiple things over, comparing multiple things. A line graph is one thing over time. And a frequency table is just that, how often? So if we look at this table up here, world's busiest airport, I'm comparing Atlanta, Chicago, London, Tokyo, and LA with the number of passengers. Well, that's not really a list, and it's not a frequency. So it is a bar graph. I'm comparing multiple airports, not comparing one airport throughout the year. So the answer is B. Okay, I'd like you to do your QCs and your CYU, and we'll go over it the next time I see you.